Okay, let's finish this off and talk about Newton's third law. You can't touch something without being touched in return. Like the lady who is throwing that ball forward, which is going to propel her backwards. Or the guy shooting the shotgun, which is going to obviously shoot the bullet forward and going to push back against him in the form of a kickback. Take a look at this example right here. And again, I don't recommend you try this at home. But here you can see obviously a guy's kicking it. But focus, all right, after we're done watching that, focus on the guy in the white shirt here. Look at what happens to his speed. He's going forward and then almost completely stops. Remember, he kicks the guy, but in return, he's actually pushed back as well. So, Newton's third law, forces come in pairs. For every action, there's an equal and opposite reaction. Like the air is going to rush down from the balloon, and the reaction is going to be the balloon is going to go up. If you're standing on a skateboard, you're going to try to push forward to push yourself forward, but that's, of course, going to push the skateboard backwards. This right here is a perfect example of Newton's third law in action. He did not account for that. So you'll notice as the pop bottle goes forward, of course, the only way for it to go forward is by pushing something backward. In this case, that, of course, is the water in the form of an air pump. He did not account for Newton's third law, and right there, he realizes it. Poor guy. Or another one right here, a pretty cool shot of a champagne bottle, and you'll see the cork pushing out. But focus on the bottle for just a minute. So the cork shoots out, but the bottle goes backward. So there's an action this way, but there's a pair. It has to push back the other direction as well. Like your tire pushes on the road, and of course the road is going to push on the tire. The rocket is going to push the gas, and the reaction is the gas is going to push the rocket forward. A guy is going to pull on the spring, but the spring is actually pulling on the guy at the same time. The earth is actually pulling the ball down, and it's hard to believe, the ball actually pulls on the earth as well. So these are action-reaction, a pair of forces. Copy and draw one of these into your notes. Pause right here and copy. You can see right here, we're going to get a proof of Newton's third law in just a moment. We got a guy with a 50 cal machine gun there, and what's going to happen? Well, as the bullets are going to be shooting forward, there's going to be tremendous kickback pushing the boat backwards as well. That's probably what has the trolling motor there to, sort of account for that. But the gun is going to push against the bullets, but the bullets are going to push against the gun as well. We have this guy right here. The athlete is going to pull up on the weight, but of course the weight is going to pull down on the athlete. He's going to pull up, but it's going to be pulling down, a pair of forces. The pogo stick is going to push down against the ground, and the ground is going to push up against the pogo stick. This is how they work. The dogs are going to pull against the leash, but the leash is actually going to pull against the dog, so they're going to feel that as well. This is a pitcher, Joel Zumaya. At the time I made this, he had one of the fastest pitches ever. He's going to push his hand against the baseball, but of course the baseball is going to push back, and it's going to slow his hand down a little bit. Doing a pole vault. The athlete is going to push down against the pole, but the pole is actually going to push up against the athlete. That's how you go up and over. Here we have a really cool artillery shot right there. You can actually see the projectile right there. The tank is going to push that projectile up, but that projectile actually pushed down against the tank as well, so it felt that as a recoil. Here's a pretty good example of what kind of power we're talking about for recoil. It's a lot of power. I'll show that one more time. It's going to push one projectile way out there, but it, of course, is going to be pushed very, very far back as well. Action, reaction. Birds as well. The bird will push down against the air, but the air is going to push up against the bird. Notice this example here. This is a bird just trying to run across the surface of the water. So the water has to go backwards in order for the duck to go forwards. If the water did not go backwards, the duck couldn't go. It has to push against it. Action, reaction. Same thing with dolphins. The dolphin is going to push against the water, but the water is going to push against the dolphin. Of these previous 8 slides, I want you to copy and draw one of them into your notes. And when you do so, include the arrows to show the equal and opposite forces, like the pitcher. He's going to push it forward against the ball, but the ball is going to push back against his hand. Or the tank, it's going to push that projectile up, but that projectile is going to push down against there. Pause right here so you can draw and copy one of these into your notes. Let's take another example at a gun here. The gun, of course, is going to push against the bullet, and the bullet is going to push against the gun, but this raises the question. Both the gun and the bullet are pushing equally. Why does the gun accelerate slowly and the bullet accelerates very quickly? Well, the answer is actually Newton's second law. We got to tie that in. The bullet has a small mass, so you're going to get a very large acceleration. On the other hand, the gun has a large mass, so you're going to get a small acceleration. So same amount of force, small mass, big acceleration. Big mass, small acceleration. But in both cases, I have the equal force there. And this girl's about to get a life lesson by shooting a gun. It's gonna, the bullet's gonna push out that way, but it's gonna push the gun right up against her face. I wish she's got glasses on, so there's that. Not really, that's gonna be much help. Here you can see another example of action-reaction, gonna push that projectile outward, and of course it's going to kick back. Yeah, Newton's third law. Can't forget it, even if you're in the military.